a must-have chord dynamic displacement manual for our designers. The case we studied this week is rope deformation. The effect in this case is this. Okay, here we have the final result of the rendering. What about his effect? He actually got it from his motion blur. Here are the lines. Then through motion blur. And then get this feeling. Okay, what about this effect? It was an effect of watching Houdini at that time. Then I convert it. Use our chord to do this effect. Okay, let's take a look at our project. Then take a look at its specific logic. Then follow the idea. Finally, I'll do it again. This is our project. He is actually a circle of cloned lines. Then perform a line segment calculation on him. And then what's at the end? Use a deformation called morph. That is to say, the calculation part. Make a mix with its original part. Okay, let's take a look. Okay, first we have a helix. It's a spiral. Let's change the spiral into a straight line. Then set its number of subdivisions. Then follow it with the number of points. Then we use clone radiation mode. Then set up 600 roots. He has a radius. There is a circle left in the middle. Here. Okay, this is our model. Then we connect it to. We use an instance. The object of the instance is the connection we just made. Then, let's give another link here. Then use spherical domain. Vertex domain. It has a vertex domain here. And what about inside the domain? We use a spherical domain to blend the animation. Here the vertex map. We use this sphere domain. The impact is on this part. It means that we need to lock this area. Don't let it affect. That's what I mean at this time. This piece will be locked here. Do not participate in our calculations. And what about the solution? We set Ctrl-D in the project settings. Simulation scenarios in our project. This gravity is 0. It won't fall down without gravity. In future simulations, these are basically the default settings. Okay, and then inside the label of our rope. These basically do not have any settings. Mainly to give a wind force. Let's take a look at our force field. Our wind has the power to blow upwards. Let him blow up. No domain is used here. Let's turn on the wind first. Such a wind blows upward like this. Well, this is the power of the wind. This distorted object. He has intensity, probably around 20. Then change the scaling value to 8. Because that's how he is. Let's exercise randomly like this here. Then cooperate with the wind field like we just did. He will go up like this. Okay, this is ours. The dynamic solution part of the spline. It is also our core content. Good, this is what we are going to do in the first part. Okay, and after doing this, let's close these. We bake it. We choose this connection. We export it to this animation of ABC. This is what we have cached. Current status. After turning to the opposite direction, we use this pose deformation. In posture deformation, what about our domain? Here we use a circular domain to do a scaling. Okay, do a zoom like this. Let it do this deformation of this AB spline. In the future, it will be in our transformation. Let's open this decay. Let's take a look. Decay is Chinese here, called recession. Then there is a delay. After we use the maximum recession, it is 67. Then he will have one here. This kind of change here. Then give him another delay. Defer using a flex. It will feel like a wave here. Okay, this is our dynamic part. Okay. Okay, let's do this case again. Let's save it. Use a spiral here. Then change its starting radius and end radius. Change it to small and change its points value to 20. This is the default 8. Then its height is 800. Select the spiral. Hold down the Alt key to add a clone. Then we change the mode to radiation. Then change this quantity to 400. Radius increased to 850. OK. OK, let's give him a connection at this time. Remove this weld. Add a blank. Our renamed line segment source. OK, let's hide it. Then we use an instance. The object of the instance is our connection. Right-click on other tags on the instance. Our vertex map. Select this. Then we use a sphere domain. OK. Then set the size of this range. OK, let's add a simulation tag to it. Use rope. Then blend the animation. Use nails. Then map. Let's take this vertex map and throw it in. Let's play the timeline. Then pay attention to it here. Now it's the other way around here. Here we have the vertex map. Here we set the accent. We use reverse. Project settings Control D. In the scene, we change this gravity to 0. Then in simulation, here we are in the force field. We first need to give it a wind. Blow upward. Set the coordinates. Let's change this P here to 90. Then we let him blow up. Let's first take this time. Change it to 200 first. Play next. For example, change it to 20. Because we don't want it to end up flying too high, we need to limit it to a certain height. 20 may be a bit high. Let's change it to 10. OK. Then we use the flow. Let's change its intensity to 10 and scale it to 100. We can change the zoom value. Scale to 10. Change frequency to 50. A good example would be like this. Good. Then we give this example. It also gives a connection. Close this weld. Save it. Add a blank. Ours is called Rope Dynamic Solution. Good. Then we need to cache it. We choose this connection. Type your name. Let's right-click and bake it as a lembi ABC. OK, let's cache it. This is the line segment we cached. Our original ones can all turn it off. Then we create a new blank. We call this deformation. Select line segment. We right-click the current state to change the object. Let's hide this. Change the name of this. Now he won't have any animations. I want to delete the label of his transformation. He can still move. Okay, we won't move now. Okay, let's add a label to him. Assembly posture deformation. Let's check this point. Then we take this baked ABC. Let's throw it over. He will ask you if you want it as an absolute or relative. What we use is, let's delete this gesture 0. Okay, let's choose animation. He will move at this time. We close. He won't update this, right? He is related to us. Well, we are in the deformer at this time. We use this deformation. Deformation gives us this line. We use this here. Object deformation. Let's give this label. In the domain, we create a torus domain. We give him K a frame. At frame 0, we make it smaller. For example, to 100. Let's enlarge it. Go here. Then it gets to 150 or 170 or 160. Then move on. And then what's at the end? It disappears instantly. Okay. This is our transformation. Good. Let's add some effects to it in the transformation key. Let's first add a decay. We use the largest. Then add a delay to it. Give him a little more flexibility.
Don't disappear completely.
Let's keep a little bit. Otherwise, he might not be particularly good. Okay, this is our dynamic part. Let's take a look at our rendering section. In terms of rendering part, mainly doing more work on materials. After setting up, we open our rendering window IPR. Let's click on Render. Octane label. Object tag. Then render the hair. OK. Then you need to adjust this parameter. 0.1, 0.1. Let's put it to the side. Well, play it. This is our material part. Let's take this depth of field, close it first. First of all, it has no motion blur here right now. We check this transform vertex. Let's open this. Let's play it again. Refresh. We make sure that the motion blur here in the camera to open. Notice that the value we have here is very high. I have set 5000 here. Motion blur is set to 5000. We can see it here now. We have already appeared here. Motion blur effect. Then the blur value here in the camera. You need to pay more here. Set it as default, right? You should be stronger here. For example, was it 5000 just now? You even gave me 15,000. Right, there will be something more beautiful like this here. This effect. Then this is the part of our camera. Then let's take a look at our material. This material is more important. Let's double-click our material ball. Then we enter node mode. Let's take a look at what I've set up. I just have some self-illumination here. If we remove this self-illumination, it's the darker one now. Some self-illumination is used here. Later, let's take a look at what I'm using here. Then a gradient. Gradient. Let's connect this to here. Diffuse and self-luminous. Here a projection is used. Projection is done using a spherical. Then use a sphere here. It's after this radio here. He is now in a spherical shape. After projection, the colors used here for these gradients. Here is what I set up. He will be spherical like this. This feeling. This value. What's your number here? This can be adjusted at will. The color that comes out. It can be adjusted at this time. This is our color. In the future, I will adjust another one here. Also a projection here is using an XYZ to UV DA. This is also a gradient for me. Then let's take a look at what I'm adjusting here, some colors. I am using this Y-axis. I want it to be the world coordinate axis. XYZ to UV DA. Then limit it here. The black and white information on the Y-axis. I can adjust it here. You see, right? I am prefixing him here. Let him set a limit on this height. Let's multiply these two. Then he will get us this piece of his bulge. The part of him on the ground that doesn't move. We will not do any coloring. Let him be black. Okay, this is the material for our rendering. Core part. Okay. Well, here, as for the camera here, what can we turn on here? I just turned off the depth of field here, right? I can turn on the depth of field here. Then use the generic. Then use this polygon and then defocused form. Then our glow. Okay, this is basically our case today. Some technologies used. Okay. If it's not bright enough here, you can also adjust it here. And even this saturation. You can also adjust it here. This light spot may be too strong. You play again. Here we send it again. Let it refresh again. Okay. This is our case today. The final effect of this case of rope deformation. Okay, let's stop here this week. See you next week. This is Dynamic Design. Thank you for watching. See you in the next class. Bye.